Good morning, everyone. This is AP Chemistry Chapter 4, Lesson 7. In this chapter, we're going to talk about precipitation reactions and how you solve quantitative problems with precipitation reactions. So the first thing that you should know is that these are very similar to mass-mass problems. Oh, it's kind of hard to get used to using this it's a portable little tablet, but it doesn't tell you where you're writing, so it's a little hard to get used to it. So forgive my writing and my slow writing. The difference between these and mass-mass problems or limiting reagent problems is that in those problems, obviously you're given a mass and they want you to find another mass. Usually in these problems you're given molarity and volume and they want you to find a concentration. But the process that you do to get there, remember, convert what you're given to moles, use the moles of the limiting reagent to find the moles of the product, that's all the same. It's just now we're finding moles, we have another way to find moles. So the first step in any problem like this is to write and balance the equation. Whoops. Now, in your notes, I tell you that you should write and balance the net ionic equation. Sometimes that's easier, sometimes it's not. So when I say the equation, it's really whatever you prefer to work off of. You can work from the complete molecular, you can work from the complete ionic equation, or you can work from the net ionic equation. It really depends on the problem as to which one's easier. So maybe you just want to start with the complete molecular, and then as you get more experience with these, you can start playing around with the type of equation that you use. The second step is, I think it's very important to identify the phases of all reactants and products. It will help you when they ask specific questions, like what is the concentration of all ions left in solution? Well, you want to make sure you don't count the solids, and you will unless you write down that something's a solid. So identify all phases, not of reactions, of reactants and products. Oh, this is very neat handwriting. I feel like Taylor. Okay? Next, after you've written and balanced the equation and fill in the phases, you want to take the moles find the moles of whatever's given. Okay? Typically this is going to be different because they're going to give you molarity and volume. So you're going to have to rearrange this formula to solve for moles. Moles will equal molarity times volume. Okay, if you think of slapping molarity over 1 and cross-multiplying to solve for moles, the moles equal the molarity times the volume. So you take the moles of you take what's given and you convert it to moles. If two reactants are given, right? You have to do a limiting reagent problem. Then you'll do a mole-mole. You'll use the moles of your limiting reagent to find who they ask you about. Okay, so you use the moles of your limiting reaction to find your moles of your unknown. And then often they want concentration. So I'm just going to write here, because sometimes they want mass, convert moles to desired unit. So if it's mass, you know to multiply by the formula mass. If it's concentration, that is, remember, molarity. And molarity equals moles over liters. Okay? So all these problems can be different, but that's a really generic form of what you need to do to solve these problems. Let's walk through a couple examples. Okay, so this is example number 1. It says calculate the mass of solid NaCl that must be added to that much silver nitrate to precipitate all of the silver ions in the form of silver chloride. So you have to be able to read these problems and figure out who is reacting. And if you look at the question, you should recognize that we are taking NaCl and we're reacting it with AgNO3. And they're going to switch partners, so you're going to have the Na with the NO3 and the Ag with the Cl. Okay? Before you go to balance, you should make sure you have made neutral compounds. So think about charges. Na is +1, NO3 is -1, they equal 0. Ag is +1, Cl is -1, they also equal 0. So we've made neutral compounds. We go to balance, everybody's balanced, and now we fill in the phases using our solubility rules. We know anybody with, we know anybody with group 1 in it is solid, however, or is soluble. However, this tells us that it was solid NaCl that we're adding to the solution. So that will not exist as ions, so it's starting as a solid. It's a solution of AgNO3 and all nitrates are soluble, so we'll call that aqueous. All nitrates are soluble, so that's aqueous. And then chlorides are mostly soluble, but silver chloride is an exception. So there we have our phases. I'm going to put the given information underneath who it's given about. I like to do that to organize myself. So I'm given 1.50 liters of 0.1 molar silver nitrate. And they want to know how many grams of this you need to add to turn all the silver ions here into solid silver there. So basically, how much NaCl do you have to add to react with all of your silver nitrate? So I've balanced the equation, I have the phases, now I'll find the moles of what they gave me. The moles of silver nitrate equal the molarity of silver nitrate times the volume. It has to be in liters. So you'll have 0.1 times 1.50, and you should come up with 0.150 moles of silver nitrate. This is not a limiting reagent problem because they did not give me amounts of both reactants. So my next step is to take the moles of what they gave me information on and convert it to moles of what they are asking me for, which is the NaCl, which is not really a hard problem here. This is the only time I use the coefficients in the equation. According to the equation, for every 1 mole of silver nitrate, I will need 1 mole of sodium chloride. So that'll give me my moles of sodium chloride, and they wanted grams. So I'll just continue this, if I can. 1 mole of sodium chloride, I think it's 58, but let me check here. Let me calculate it real quick. $22.99 plus $35.45. It's 58.54, right? Isn't that the formula mass of sodium chloride here? 58.54. So we can multiply by all the tops, 0.150 times 58.54, divide by all the bottoms, and we should get our final answer. I'm going to write it up here because I don't think I'll have enough space. 8.78 grams. And that's our final answer, okay? Really, it's everything that we've already done. We're just doing it with a new type of reaction that we haven't seen, okay? So now we'll go to the next sample problem. This is a little bit different. So it says when aqueous solutions of Na2, SO4, and PbNO3 are mixed, PbSO4 precipitates. Calculate the mass of PbSO4 formed when those amounts are mixed. Okay. So again, we want to write the reaction. We're mixing Na2SO4, and that's an aqueous solution. And we're mixing that with PbNO3, 2, which is also aqueous. Whenever you mix two solutions, they wife swap, so you're going to make Na with the NO3. Na's plus 1, NO3's minus 1, so we're a neutral compound there. And we're going to make the Pb plus 2 with the SO4. Again, we know it's plus 2 because here it took 2 nitrates to make a neutral compound. So right now we're not balanced. We need to get balanced by simply just putting a 2 there. And that's our reaction. We should apply our solubility rules to our products here. All group 1 compounds are soluble. And they already told you that lead sulfate is a solid. It's a precipitate, which means it's a solid. So I write the given information under what's given. I like blue for that. So I'm going to take 1.25 liters of 0.05 molar and 2 liters of 0.025 molar. Shh. Do you hear that? Not the fish tank. The bells and whistles. You are given amounts of 2 reactants right here. This is a limiting reagent problem. So we have to find out who the limiting reagent is here before we can use it to find the mass of PbSO4. So we find the moles of each one. The moles equal 0.025 times 2, which is going to give us 0.05 moles of this, I think. It's early on Sunday morning. I just want to be sure. I hate when it doesn't flip. 0.025 times 2. 0.05. Yep. Why do I doubt myself? And then moles here equal 0.05 times 1.25. 0.0625. Now, typically we would do a mole-mole problem or whatever method that you choose, but here's a little shortcut. These are in a 1-to-1 ratio. They have the same coefficient in the formula here. So that means whoever there is less of is the limiting reagent. So when the coefficient is the same, whoever there is less of is the limiting reagent. So that means that the Na2SO4 over here is my limiting reagent. And I will use the moles of it to find the moles of my product. So I'm just going to get a new sheet of paper here. Whoops, maybe. And use the moles of my limiting reagent, which were 0.05 moles of the Na2SO4 to find the moles of whoever they asked me, which was the PbSO4. And they're in a 1-to-1 ratio. And then you convert that to grams by multiplying by the formula math. Okay, so I made a mistake here. I'm back. Sorry, I had to fix it. I was off a decimal point because I divided by I multiplied by 0.5 instead of 0.05. So the answer you should come up with when you multiply by the formula mass is 15.2 grams if you go to 3 sig figs, 15.163. So we're going to do some more practice with this in class tomorrow. Have a great day, everybody. We'll see you tomorrow. Bye-bye.